Hey guys, this is Coach Brian going over the 8.3 notes with you, all about angles of elevation and depression. So this is all still trig related, like all of Unit 8 has been, and it will still use sine, cosine, and tangent. But what we're specifically looking at when we're talking about an angle of elevation versus an angle of depression, it's all about a horizontal line and a line of sight. So if we look down here, there's a special note. It says the angle of elevation or depression is the angle between the line of sight and the horizontal line. And then if we look at the two examples we have up top, a line of sight implies that somebody is looking at something. And so we have an observer, okay? We have an observer in both of our situations. And the horizontal line is going to be a line created just by going straight out from that observer. So in the case of the person in the hot air balloon, the line is up in the air. The person on the ground, the line is the ground, okay? And then our second line is going to be our sight line, okay? And that's a line straight to whatever the observer is observing, whatever they're looking at. And so sometimes that goes down, and sometimes that means they're looking up. And so that determines if we have an angle of depression or elevation. And we can use those angles to create triangular situations where we can then use trig to find missing sides, numbers, and all that good stuff, right? All right, so let's look at a few examples. The angle of depression from a plane to a grove of trees is 26 degrees. So we have this airplane flying straight ahead. That's the horizontal. But from the cockpit, the pilot or whatever is observing this grove of trees. So they're looking down on something, which means they're creating an angle of depression, and that angle is 26 degrees. Now we want to know the altitude of the airplane. How high above the ground is the airplane? So using what we've been studying, we know our angle is here, and we're looking for the opposite side. And we are given the diagonal, which is also known as the hypotenuse. So you'd ask yourself, which trig function uses O and H? And that would be sine. SOHCAHTOA, sine, OH. So we would set this up by saying that the sine of 26 equals opposite, which is my altitude that I don't know, over hypotenuse, which is 7. And then to solve for this, we need to isolate the A. So we multiply both sides by 7. And the 7 times the sine of 26, you can just type that straight into your calculator. 7 times the sine of 26 equals 3.069. And so you might be wondering, 3.069 what? So you'd look back at your picture and see that that's measured in kilometers. And that is how high above the ground our plane is flying. Next, looking at question number 2, it says the angle of elevation. So this is going to be our upward angle. And it's from Fred. All right, here's Fred. And this is his work building. And it says that this angle is also 26 degrees. And we're trying to figure out how far is Fred from the base of the building. So we're trying to figure out this side, okay? Missing side right here. And we are given the height of the building, 95 feet, which when we relate that to our angle of elevation is the opposite. So we're looking for the adjacent, and we are given the opposite. Which trig function uses opposite and adjacent? That would be tangent. TOA, SOHCAHTOA, tangent. So the way we would enter this is we would say the tangent of 26 degrees equals opposite 95 over adjacent, the side I don't know. And then we would use the same process. We need to isolate the x. We need to get it by itself. So we would multiply both sides by x. And then we would divide tangent of 26. All I'm doing here is rearranging my formula so that it actually solves for what I needed to solve for. And when you type into your calculator 95 divided by the tangent of 26, we get that the building is, Fred is 194.779 feet from the building. $194.779 feet. All right, guys, on this next question, it says a person is standing in their high-rise apartment. So let's go ahead and draw out the situation. All right, they're up in the high-rise. They're looking down here. What do they see? They see a dog, all right? They see a dog over here on the ground, all right? It's just out roaming, and they are looking down from their high-rise at that dog. And it says that they are looking down with an angle of depression, depression down at 75 degrees. And they see this dog that is 120 feet away from the building. So the dog, to the building is 120 feet. And they want to know the height of the window. So we're looking for this side, the height of the window. And as you can see here, we've created a right triangle. And in this right triangle, we have our angle. We are looking for the opposite side. And we have the adjacent side, the side next to the angle. And so which one uses opposite and adjacent? Which trig function? OA. That would be tangent. SOHCAHTOA, TOA, tangent. So when we're using tangent, we could say that the tangent of 75 equals opposite over adjacent. And we would want to get rid of this 120. And so we'd multiply both sides by 120. And you could type into your calculator 120 times tangent of 75. And we get that the building is 447 feet. 447.846 feet high. Maybe not the building, but the window, whatever window this person's in. They're 447.846 feet in the air. All right, last one. This one's a little bit tougher. It's got this little extra detail in it that makes it a little trickier. It says that Betty's eye level is 5 feet. So we're saying right here that Betty's eye level, 5 feet. And the angle of elevation from her eye line, or the line of her eye level, is 43 degrees, elevation, so the upward angle. So we're trying to figure out how tall this radio tower is when she's looking, at 5 feet above the ground. Now, the only piece of information that we have is that the angle is 43 and the hypotenuse is 250. And we're trying to figure out the height. So from that angle, we are looking for the opposite side. and we are given the hypotenuse, okay, the hypotenuse. So at this point, you know that sine uses opposite and hypotenuse. And so we could say the sine of 43 degrees equals the number I don't know over the hypotenuse. And to solve for this, we multiply both sides by 250. And when you put 250 times the sine of 43 to your calculator, you get 170.500 because it's 0.4995. So that would round up. Okay, round up. Now, that is the height from her eye line to the top of the tower, so we can't forget about this additional 5 feet. And so to that total, we would add 5 feet, and the total height of the tower would be 175.500 feet. The end. All right, hopefully this helped. Remember, the angle of elevation is always between the horizontal and the line of sight, and if it's looking up, it's going to be an angle of elevation. If they're looking down, it'll be an angle of depression.